Hi everyone, I am NS Kavisundar. I am pursuing BE Aerospace Engineering in SNS College of Technology. Now I am here to present the PPT about analyzing the impact of advanced material on the performance and efficiency of aerospace propulsion system. The introduction: ion drive, solar cells, fission and fusion. Some of the ideas for powering the next generation of spacecraft have an aura of scientific. Litchfield recommended research to improve conventional systems such as chemical rockets, electrothermal engines, and ion drives. Chemical rockets. Chemical rockets were the powerhouses of space age, but after 90 years of development, further engine refreshment are not expected to lead to major improvements in terms of thrust. These rockets are fundamentally limited by the energy held in chemical bonds, especially towards generating fuel at the destination planet, rather than carrying it all on board. For example, those on Mars might split ice from the polar caps into hydrogen and oxygen to use a rocket fuel. Electrothermal rocket. These engines use electrical energy to create a superheated plasma and fire it through a supersonic nozzle to generate thrust. This kind of engines have been used in Russian satellites since the 1970s, and Lockheed Martin A2100 satellites using hydrogen as fuel. These engines are efficient by the thrust. They generate to extremely low, meaning that only like us used with the orbit satellites in orbit. Ion drive. Now we are getting to the furnace-stick stuff. The ion drive engine is a thruster where molecules of the unreactive fuel, such as oxygen, are given a positive or negative charges and accelerated by an electric field to a shot out to bake. The thrust is incredibly low, equivalent to the pressure exerted by a sheet of paper of a palm of your hand. On engineers is a very slow of pickup speed, but over a long range mission that can be delivered 10 times as much thrust per kilogram of further as a chemical rocket. Solar cells. In this picture, particles of light called protons carry momentum like ping pong balls bounding off a wall. The solar cells idea is catch enough of them to pick up the significant thrust. As spacecraft with a large enough sails with eventually reach incredibly speed without carrying any fuel. Plasma propulsion engine. The engine are like high octane versions of the in ion drive. Instead of a non-reactive fuel, magnetic current and electric potential accelerate ions in plasma to generate thrust. The most powerful plasma rocket in the world currently, the variable specific impulse magnetoplasma rocket, being developed by AD Astra Rocket Company in Texas. Thermal fission. Conventional fission reactor could heat a propellant to extremely high temperatures to generate thrust. Through no nuclear thermal rocket as yet flown, the concept came close to friction in the 1960s and 1970s, with several built and tested on the ground in the US. Continuous fission. Fission powered rocket effectively try to recreate the power of the sun by superheating fuel to hundreds of millions of degrees until the atomic nuclear fission to generate more energy. A fission rocket would be hundred of times more efficient than the best chemical rocket. Most of the strategies of deep space transport involve building bigger and more powerful engines. But what about shrinking the spacecraft engine, nano spacecraft? In 2009, researchers at the University of Michigan developed a kind of nanoscale engines that could be patterned onto a silicon chip. It works a bit like a tiny particle accelerator, very high velocities using simple electric field between charged plates. Each chips contain a million of tiny electric launchers. Thank you.